Good morning, class. Welcome to today's explainer. I am so incredibly pumped to have you all here. So, picture this. You're trapped on a packed, roaring airplane, right? The engines are deafening, but the second you slip on a pair of modern noise-canceling headphones, all of that chaos just vanishes. It feels exactly like magic. But today, curious students, I'm going to show you the mind-blowing live science experiment that is happening right on top of your ears. On one side, we've got the overwhelming, chaotic roar of airplane engines and, babies crying. On the other side, that sudden, glorious illusion of complete silence. But as any good student of science knows, there is absolutely zero magic happening here. What you're actually experiencing is real-time digital signal processing. It's this remarkable, brilliant blend of physics, high-level math, and sound engineering that literally manipulates the very nature of what you hear. Here is our quick syllabus for today's lesson. We'll be hitting the illusion of magic, the physics of sound, flipped, the mirror image, 4 steps to silence, the timing problem, and we'll wrap up with the future of sound. Let's dive right in. Section 1, the physics of sound, understanding the target. Because before we can completely cancel a sound out, we really need to know what our target actually is, right? Think of it like this. Sound isn't a physical object you can just reach out and grab. It's a wave of pressure traveling through a medium, like the air that's all around us. When an airplane engine vibrates, it violently pushes nearby air molecules back and forth in this massive chain reaction, creating invisible waves that travel outward until they physically crash into our eardrums. And these invisible waves really have 2 main personality traits we have to deal with. First up is frequency. Measured in hertz, frequency just tells us how fast a sound wave is vibrating. Low frequencies give us those deep, rumbling sounds, like the airplane engine, while high frequencies give us sharp, piercing sounds, like a bird chirping. The second trait is amplitude. This determines the actual physical size of the wave and its overall loudness. Bigger waves literally just mean louder sounds. Moving on to section 2, flipped, the mirror image. Now, this is where the true physics of silence comes alive through an amazing principle called destructive interference. To really wrap your head around wave interference, I want you to imagine 2 dancers trying to move together on a stage. If they both step to the left at the exact same time, their movements sync up beautifully, and their combined energy is noticeably stronger. In physics, when a wave's peak meets another wave's peak, the sound gets louder. That's called constructive interference. But what if one dancer steps left at the exact millisecond the other dancer steps right? Well, they collide, they fight each other's momentum, and they stop completely dead in their tracks. When a sound wave's peak meets another wave's valley, they fight each other, and the sound is canceled. That right there is destructive interference. So the whole trick boils down to this mathematical mirror image. If you have a really annoying sound wave, let's just call it y equals sine of x, and you introduce its exact mathematical opposite, y equals negative sine of x, what happens? They sum up to nearly 0. The audio is effectively erased. Physics takes math and turns it into pure silence. Section 3, 4 steps to silence, inside the DSP. First, we have to separate the old school tech from the new. Simple, passive headphones, they just try to physically block noise using dense foam padding and a tight seal around your ear. It's pretty much like closing a heavy, solid door to block out a noisy hallway. But active noise cancellation, or ANC, it goes on the offensive. It actively fights those incoming sound waves using a tiny supercomputer in real time. And it pulls this off in 4 fast, distinct steps. Step 1, tiny microphones detect the external noise. Step 2, a digital signal processor, or DSP, analyzes that sound. Step 3, it generates the exact anti-noise. And step 4, destructive interference physically occurs in your ear. Let's look a little closer at how this tiny supercomputer actually behaves. In steps 1 and 2, the microphones placed on the outside of your headphones are basically serving as the ultimate listeners. They're constantly monitoring the environment. They pick up the engine hums and the street traffic, convert those acoustic sound waves into rapid electrical signals, and fire them straight into the DSP. The processor then incredibly quickly measures the frequency and predicts the incoming wave patterns of the noise. Now, step 3 is where the real magic happens. The processor takes that incoming wave and literally flips it completely upside down. It mathematically creates a perfect inverse mirror image of the unwanted sound wave. Basically, it generates that opposite dancer we talked about, stepping in the exact opposite direction to stop the motion dead in its tracks. Finally, in step 4, the headphone speakers instantly play that newly inverted anti-noise straight into your ears. The external noise in the freshly generated anti-noise violently crash into each other inside the ear cup. Positive pressure perfectly meets negative pressure. They collide, completely erase the sound wave, and dramatically reduce the noise to give you that incredible perception of total silence. Section 4, the timing problem, racing the speed of sound. Because honestly, the engineering hurdle required to make all of this actually work is absolutely massive. 343 meters per second. That is roughly the speed of sound traveling through the air. Because sound moves that incredibly fast, your headphones have mere milliseconds to detect the noise, analyze it, flip the math, and play the anti-noise. If that anti-noise arrives even a tiny fraction of a millisecond too late, it won't align perfectly, the dancers won't collide properly, and the cancellation will just completely fail. And this strict speed limit is exactly why your headphones are practically flawless at erasing the deep, predictable rumble of a train, but they really struggle with sharp, unpredictable sounds. You see, low frequencies are continuous and slow changing, which gives the little computer plenty of time to predict the wave. High frequencies, on the other hand, like a crying baby or the sharp clack of a mechanical keyboard, are extremely rapid and have very short wavelengths. They require such intense split-second timing that it is just incredibly hard to perfectly erase them. So to win this crazy race against the speed of sound, engineers use a few different mic setups. Feed-forward systems put the mics on the outside to catch the noise as early as possible. Feedback systems put mics inside the ear cup to measure what your ear is actually hearing in real time. Today, the absolute premium flagship headphones use a hybrid system, mics on both the outside and the inside, giving the processor maximum data to correct the audio right before it hits your eardrum. Section 5. The future of sound, AI, and acoustic control. We've gotten really good at erasing sound. So where do we go next? Well, the tech is evolving from just erasing reality to fully controlling your acoustic environment. We already have transparency mode, which cleverly uses this exact same microphone system in reverse to naturally pipe outside audio in. But looking just a bit forward, artificial intelligence is being trained to recognize specific voice patterns, dynamically adapt the cancellation strength depending on whether you're walking down a busy street or sitting in a quiet office, and even completely scan your personalized ear shape for maximum effectiveness. So I'll leave you, my curious students, with this final provocative thought. What if, in the near future, tomorrow's headphones allow you to entirely mute the obnoxious, distracting hum of street traffic, but flawlessly let through the human voices of your friends walking next to you? Imagine a future where science doesn't just erase reality with silence, but literally empowers you to perfectly curate exactly what you want to hear. Thank you so much for joining me for this explainer. Keep asking those great questions, and I'll catch you next time.